Today we're going to be covering the notes on what is a literal equation. So, in solving literal equations for a specific variable. So, first of all, what is a literal equation? An equation with more than one variable. So all it is, if you look at these problems down here, you'll notice that not only is there an x, there's a y, or these that are actual formulas, certain forms. This is called standard form. We're going to be seeing this a lot this year. So we're going to practice a couple of these, and I'll leave some of them for you to do on your own. So problem number one, let me go ahead and make this a little bit bigger for you. Problem number one, we have x minus y equals 5, and we need to solve for y. So the very first thing that I like to do in these problems is I've identified y is right here, and it's currently a negative. I don't want to deal with negatives. So in order to make it positive, I need to put it on the other side. So what's the opposite of subtracting y? I'm going to add y. I'm going to treat it just like a number. The only difference is when I add it or subtract it, I'm not adding or subtracting to an actual number. I'm not doing any arithmetic. I'm just moving pieces around. On this left side, this goes away. It zeroes out, which is what I want. I have x equals 5 plus y. Again, I want to get y all by itself. So if I was solving for x, boom, I'm done right here. But I'm solving for y. So I need to do one more step. I need to move this 5 away. So instead of adding 5, I'm going to subtract 5 because 5 right now is positive. This leaves me with x minus 5. Again, I don't know what x is, and right now I don't care. I'm just moving these pieces back and forth. Equals y. And you can either leave it like this, but if you're more comfortable, you can write it as y equals x minus 5. I didn't do any arithmetic. I didn't really add or subtract any values at all. I'm not using a calculator to calculate anything. All I'm doing is moving these pieces back and forth over this equal sign. And just like in our previous notes, if we change sides, we change signs. So if I look over here at problem number 2 has P, capital P, equals 2W plus 2L. And we have to solve for W. Looking at this, you may understand or may recognize this. This is for the perimeter of any sort of like rectangle. 2 width plus 2 length. When they're added together, their sums create the perimeter. So I'm going to solve for W. So the very first thing is, just like every two-step problem, I'm going to use inverse operations. There's no parentheses, so there's no distribution. I'm going to use inverse operations to get W by itself. I first deal with adding and subtracting. I have plus 2L, so I'm going to subtract 2L. Oop, that should be subtract, sorry. P minus 2L equals 2W, because this zeroes out and goes away. I moved it over here. Change sides, change signs. Now, this might be the most confusing part in all of this. So listen up. We have 2W right here. Instead of multiplying by 2, I want to divide by 2. And I want to make this as easy as possible. So here's what I'm going to do. If I'm dividing this whole thing by 2, I'm going to divide this whole thing by 2. So this becomes P minus 2L all divided by 2 equals W. Remember when we talked about how I always want to deal, when I'm solving equations, I always want to deal with parentheses first, because if I don't deal with parentheses, this is what you can end up with. So there's multiple ways that you could write this. you could write this as W equals P minus 2L divided by 2. You can distribute your dividing by 2 to each one. So this could be W equals P divided by 2 minus 2 divided by 2 is 1, so it's minus L. You could write it as W equals 1 half P minus L. We do have to make ourselves aware of situations like this, because if we take a quiz or a test, our answer could look anything like this, and we have to be comfortable with that. Problem number 3 is one of my favorites because it's so simple, but there is a huge step involved with it, a huge final move that we have to deal with. So we want to solve for R. Now, remember, our reverse order of operations, we deal with adding and subtracting. Adding and subtracting first. There's no adding, no subtracting. That's done. We then deal with multiplying or dividing. Right now, I'm multiplying by pi, and I'm multiplying by h. So I'm going to divide by pi and divide by h. Divide by pi and divide by h. Anything divided by itself goes away. It becomes 1, which is what I want. And I've gotten R all by itself, but something's happening to R that we haven't dealt with yet. It's being squared. We've dealt with adding and subtracting. We've now dealt with multiplying and dividing. Now we have exponents. So now we have to think of this problem and look at it and say, what is the opposite of squaring? Well, that's square rooting. And it's been a minute since we've seen it, but we just square root. And we square root the entire thing. V over pi h. This is the most confusing and difficult problem. So if you can handle this because of this huge step here at the end, you can handle that, then you're going to be golden for today. If you want to write it another way, R square root V over pi h. It could also be written as R equals square root of V divided by the square root of pi h. Actually, I don't think that works. Don't do that. I'm going to correct myself. Leave it like that. In problem number 4, we're going to solve for y. And so in problem number 4, when we look at this, we want to get y all by itself. It is right now a 2-step problem. It is adding this and being multiplied by this. So I'm going to solve it just like I would solve a 2-step problem. I'm going to deal with adding and subtracting first. Instead of adding 2x, I'm going to subtract 2x. (2x minus 2x is 0, and it goes away. I'm left with 3y equals negative 4, look closely, minus 2x. I've dealt with adding and subtracting. I'm now going to deal with multiplying and dividing. I'm being multiplied here by 3, so I want to divide by 3. This becomes 1. So y equals negative 4 minus 2x, all divided by 3. Again, this could be distributed between them. This could be y equals negative 4/3 minus 2/3 x. We have to be comfortable with that idea because our answers could look very different. It could also be y equals negative 4/3 minus 2x over 3. That one's probably the least likely. The most likely ones would either be this one and this one. Same thing up here. The most likely cases would be this one and this one. All right, you have problems 5 and 6. There is no adding or subtracting with problems 5 and 6. So it's just dividing across. Y'all have a great day. Stay out of trouble. Make good choices. Be good people.